Okay, my dear, so we're going to do dilations day 1 if you take out your packet, or you can go to OneNote if you left it at school. Okay, so dilations day 1 says, for each pair of shapes, determine if they are congruent. Circle yes or no. So you can pause here and you can fill out your do now, or if you want, you can just follow along with me because I'm going to get into it. Okay, and I apologize right now because I think my dogs are moving a little. You might hear them. Okay. So, for each pair of shapes, determine if they are congruent. Well, the first shape is a cross, and the second shape looks like an X. But if we think about it, this is just a rotation of the first picture. So yes, rotations preserve congruence. The second one, we have a big circle and a smaller circle. Well, since they're not the same size, they are not congruent. Right? Because congruent has same size. These are different sizes. The next shape are these happy faces. Well, they're very clearly not the same shape, right? This is much more elongated. It's much longer than it is taller, and this one looks like it's a perfect circle, where they're pretty much even all the way around. So, no. These are different shapes. Okay, and the last one is these like pentagons, and yeah, they look the same size and the same shape. Now, two shapes are said to be congruent if they have the same blank and blank. So if they have, we know this is if they have the same shape, oops, and the same size. Okay. Two shapes are said to be similar if they have the same blank, but not the same other blank. Well, they're similar if they have the same shape, but not the same size. Okay? Now let's look at triangles ABC and A prime, B prime, C prime as they are graphed in the coordinate plane. Please state the coordinates of triangle ABC and its image by completing the table below. So we have the pre-image rather, is the red triangle. So that red triangle, A is at 1, 1, B is at 5, 1, and C is at 3, 3, if you see that. For image triangle A prime, B prime, C prime, that's the blue one. A prime is at 2, 2, B prime is at 10, 2, and C prime is at 6, 6. So what do you notice about the coordinates of the image in blue and the coordinates of the pre-image, which are in green? Well, how do we get from that 1 to the 2 and the 1 to the 2? So how do I get from this X to this Y? Well, let's say you said add 1, right? Because 1 plus 1 is 2. Let's see if it works for the other ones. Does 5 plus 1 equal 10? No, it doesn't. 5 plus 1 equals 6. So let's see. How else can I get from 1 to 2? I can multiply by 2. Let's see. Does 5 times 2 equal 10? It does. And does 3 times 2 equal 6? Why, it does. So we could say is the coordinates of the image are twice the size of the coordinates in the pre-image. Please take a second, write that down. Okay, let's keep going. Example 2. Triangles A, B, C, and A prime, B prime, C prime are graphed on the coordinate plane. Please state the coordinates of triangle ABC and its image by completing the table below. Okay, so ABC, if you want to pause and do this yourself, you can do that. It's that green triangle. We have -9, 6. For B, we have -6, -3. And for C, we have 0, +3. A prime, B prime, C prime is that red triangle. A prime is -3, 2. B prime is -2, -1. And C prime is 0, +1. So how do we get from the pre-image points to the image points? Well, let's see. How do I get from -9 to -3? I could add 6. But does 6 plus 6 equal 2? No. How do I get from -9 to -3? Well, I could divide by 3. But what's another way to say that? Because before we used multiplication, right? So we could say dividing by 3 but what does that multiply mean? Multiplying then by how much? I hope you said 1/3. Because this, remember, this actually means division. So let's see, does -6 multiplied by 1/3 equal -2? It does. And does -3 multiplied by 1/3 equal -1? It does. So the what we notice is that the image coordinates are 1/3 the size of the pre-image coordinates. Okay. So a dilation, we're talking about dilations now. This is our new vocabulary word. It's another type of transformation, the last one we're going to learn about. I'm going to pick a pretty color. Let's pick purple. Okay. A dilation is a reduction or an enlargement. Oh, that was mad sloppy. Hold on. Okay. Ooh. I'm gonna get my pen back. Enlargement of the original figure. An enlargement means that you get bigger by a scale factor greater than 1. Remember, this sign means greater than 1. So that was like in example 1, where we multiply by a scale factor of 2 to get our new image. A reduction is when you get smaller by a scale factor, and that symbol means less than 1. That was like in example 2, when we multiply by a scale factor of 1/3 to get our new image. Okay, so let's move on. Look back at our examples 1 and 2. Was size preserved when it was transformed to our new image? Let's see, example 1. Was size preserved? Is the red triangle the same size as the blue triangle? Obviously, it kind of doesn't look anything like the same size. It's definitely the same shape, but not the same size. And example 2, is the red triangle the same size as the green triangle? No, they're the same shape, but they're not the same size. So, no. With dilation, size is not preserved. This means that the original figure and dilated figure are not, let me make that a little neater for you guys. Sorry, my pen's acting silly today. Not congruent. They are no longer the same size. Okay. So all the other properties, though, are preserved. So the angle measures, the shape, and the orientation are preserved, but not dimensions, which are the size. Okay, let's go down. So for questions 1 through 4, find the scale factor. So this is back when we did similarity. If we look back to our figures are similar, we found this scale factor by doing one side, the biggest side, over the small side, and if it was equal to another side over the small side, etc., then they were similar. Okay, recall this, where we had big sides, small sides, we compared them, made sure they were in the same ratio. Okay, we did this too. Just letting you review, refresh. If you need to pause here and look back, you can do that, right? We talked about proportionality. If they have a constant proportionality, then they are similar. So now, let's look at this. We went from 1,4 to 2,8. So let's put our x's and our y's in order. I'm going to choose a nice orange pen for this. This is x and this is y. This is x and this is y. My prime and prime, because those are our prime points. So we're going to have y prime over our other y, and see if that equals x prime over regular x. Okay, so our y prime was 8, our y was 4. Does that equal our x prime, which is 2, over our x prime, which is 1? Well, let's see. 8 divided by 4 is 2. 2 divided by 1 is 2. They do. The scale factor is a 2. Okay, let's do number 3. So we have our x's and our y's, our x prime and our y prime, goes from negative 3010 to negative 62. So we're going to have, again, our y prime over our y equals our x prime over our x. Let's see what our scale factor is. We had negative 6 over negative 30. Does it equal 2 over 10? Well, negative 6 over negative 30, if you put that in the calculator, you should get 1/5. And 2/10 reduced is 1/5. You can also get 0.2. That's perfectly fine. So since they are the same, there is a proportionality. They are a dilation. And it's a scale factor of 1/5 or 0.2 is fine. Okay? I would like you to do Get too excited there. 2 and 4 for homework. And I'll check that eventually when we get back. Okay, let's scroll down. For questions 5 to 7, perform a dilation with a scale factor of 3 for each ordered pair. So this is a scale factor of 3. That means I'm going to multiply both of my coordinates by 3. So this is my x, this is my y. I'm going to have to do x times 3 and then y times 3. So this becomes 4 times 3 is 12. Negative 1 times 3 is negative 3. That's my answer. Let's do the next one. This is my x, this is my y. This means 3x and then 3y. I'm multiplying it by a scale factor of 3. Okay. So this becomes 3 times negative 2, 3 times 0. I get negative 6, 0 as my answer. Okay. Again, I would like you to do number 7, and I'll check that eventually when I see you again. For questions 8 through 10, perform a dilation with a scale factor of 1/3. So this one I'm doing a scale factor of 1/3. Okay. So that's the same thing as multiplying by 1/3. It's the same thing as dividing by 3. Okay, this is the same thing as divide by 3. Okay. So again, this is my x, this is my y. We'll have x divided by 3, y divided by 3. You can also multiply by 1/3. There's nothing wrong with that. You can put that straight in your calculator. So we'll have 9 divided by 3 and 6 divided by 3. My new x is 3. My new y is 2. Try it again. 3 and negative 12. Okay, you have x over 3, y over 3. This is my x, this is my y. This becomes 3 over 3. My y is negative 12. Divide that by 3. Put that in the calculator. 3 over 3 is 1. Negative 12 over 3 is negative 4. Put in the calculator. Don't put in the calculator. I don't care. Get the right answer. I know you guys know how to do 12 divided by 3 at this point. I just want you to worry about dilations now. Alright, and please do number 10 also. Okay. The rest of this is also homework. So this is also homework. So please do that. And then we will do dilations 2 tomorrow. Okay, my dears.